So today, equations on both sides of the line, all right, of the equal sign. So variables are going to be on both sides. I said that wrong. Variables are going to be both sides of the equal sign. So example, we'll start off with an easy one, or not. 6x equals 4x minus 10. Do we have a variable minus 10? Yeah, I did. I thought I wrote 0. 6x equals 4x minus 10. When we have variables that are on both sides of the equal sign, before we can solve the equation, we need to get the variables all to the same side. We could do that. I'll write this problem out two different ways. We could do this two different ways. It doesn't matter which way you pick. One of them is easier than the other, but it's kind of up to you. So I prefer the method I'm going to show you first. I prefer to try to make sure that my variables stay positive and not go negative. You don't have to do that, but since this is plus 4x on this side, I'm going to subtract 4x, right over here. 6x equals 4x minus 10. I'm going to subtract 4x on both sides. That gives me 2x equals negative 10. All right? Then I divide by 2 on both sides. I get x equals negative 5. Make sense? Now, if I do it this way, 6x equals 4x minus 10. I could, if I wanted to, I could subtract 6x on both sides and get 0 equals negative 2x minus 10. Then I would have to add 10 to both sides to get it back over here away from the x. I get 10 equals negative 2x. Then I would have to divide by negative 2 on both sides to get x equals negative 5. I get the same answer both ways, but one was less work than the other. The one on the left was a lot less work than the one on the right. So I usually try, when I do these, I usually try to get everything to keep my variables positive. It's usually my end goal when I do these. So here's another one. 5 times 2x plus 4 minus 2x equals 6 plus 2 times 3x plus 12. And justify it. You tell me what my first step needs to be.
If you do the distributive property.
I would certainly do the distributive property.
5 to 2x into 4.
So it's 10x plus 20 minus 2x equals 6 plus 6x plus 24. I would definitely do the distributive property first. I would then combine like terms.
Yeah.
Right? So that's going to give me 8x plus 20 equals 6x plus 30. I combine like terms. Second step. Distributive property, combine like terms. Okay? What would be my third step?
You would get x to one side.
I would get x to one side. So that is the subtraction property of equality. I would subtract 6x on both sides. That's 2x plus 20 equals 30. Then I would
subtract 20 and then add 20 to the third.
Subtract 20 and add 20 on both sides. Again, that's the subtraction property of equality. That gives me 2x equals 50. Then I would
divide both of them by 2 and then x would equal 25.
divide both of them by 2 and then x would equal 25. Yes. Okay? And we did one thing wrong. Because I went with what she said. Can you identify where we went wrong? It's right here.
Trying to think now.
It's okay. Can you identify where we went wrong? Why is this minus 20? Why is this plus 20?
Oh, you subtract 20 on 30.
I got to do both of them. I totally went with what you said. So, see if anyone caught it.
Then x would equal 5.
X would equal 10, or 2x equals 10. That would be x equals 5. So you see where the error was. All right. How could we find that error? If we had gotten all the way to x equals 25, how would we have discovered that error?
Well, you'd have to look over it.
How would we do it, though? We would go back to the original problem and resolve it. So that is 5 times 2 times 25 plus 4. Oops, I closed my parentheses. Plus 4 minus 2 times 25 equals 6 plus, should have done this in a different color, 2 times 3 times 25 plus, close it again, plus 12. All right, so all that mess, 2 times 25, 50 plus 4, 54 times, okay, you might start to see I really messed something up because I got some huge numbers going on here. Okay, 5 times 50 is 225 plus 4 is 229 minus 50. See what I got going on? I got all kinds of mess. They're not going to do that to you. You would solve the whole problem and not get anything equal on either side. And then you would know you did something wrong. Okay? So
What were you doing, like, with the numbers?
I'll rewrite the problem. I'll make it more clear. This was the original equation.
But then how do you get 229?
I'll show you. This is the original equation.
So you're showing, like, what it'd be if x equal 25?
If x equals 25, I would have 5 times 2 times 25 plus 4 minus 2 times 25 equals 6 plus 2 times 3 times 25 plus 12.
That'd be big numbers.
Okay, I'm going to solve it now.
Oh.
Okay, so that's, if I multiply everything by 5 in here, that's going to give me 10 times 25 times 5, 125 plus 4
minus 50.
No, sorry, plus 20, because I have to do times 4, minus 50 equals 6 plus 6 times 50 plus 24. All right? So that's 1,250 plus 20 minus 50 equals 6 plus 6 times 50 is 150 plus 24. Can you tell right now that this does not equal this?
Nope.
Just,
Wait, yeah, I kind of.
I mean, that's a huge number. That's not going to equal this. You're wrong. That's how you know. The only way you could, be absolutely sure you did your equations right is to plug in whatever x is into the variable. The only way you can do that. Okay? So let's try a different one. This one's a little bit different. 10 minus 6x equals negative 2 times 3x minus 5. Okay? So 10 minus 6x equals negative 6x plus 10. All right. You can check now. I believe you. All right. Look what's going to happen when you do this. If I add 6x on the either side, what happens?
No.
They're both gone, aren't they? There's no more x. 10 equals 10.
Then that.
There's no more x. So this, when this happens, it's called an identity equation because there's no variable left. The variable is totally gone. Nothing left to our variable. That can happen sometimes. There's also weird equations where there's never an answer. Here's another one. 7x minus 2 equals 9x minus 5 minus 2x. Okay, so 7x minus 2 equals, combine like terms, 7x minus 5. I subtract 7x on both sides. Negative 2 equals negative 5. Can't happen. That equation is never going to be true. This equation is always true. No matter what we say x is, this equation is always going to be 10 equals 10. No matter what we say x is. This equation, no matter what we say x is never going to be true. Never once is this equation going to be true. Okay? So let's put this in the real life terms. Look at C on page 167. C says a fitness center has a membership fee of $125. Members only pay $5 per day to work out at the center. A non-member pays $10 per day to work out. After how many workout days is the total cost for members, including the membership fee, the same as the total cost for non-members? All right. So let's see if we can figure out what that is. So D for days. So let's do the member side first. The member side pays what?
They pay a membership fee of $125.
How many, yes. So that's plus 125 on their side. Times how many days? Or how much they?
They pay $5 a day to work out.
Okay. $5 a day. Well, how much do non-members pay? $10 a day. Okay, they pay $10 a day. Okay? Let's figure this out. Let's isolate my variables. So let's subtract $5 a day on both sides. That's 125 equals 5D. Divide by 5. What do you get?
So that would be 25.
25 days. So 25 days is how many days you would have to work out as a member to equal the cost it is to a non-member for the same amount of days. After 25 days, it gets cheaper for you as a member than it does as a non-member. But not until you get past the 25-day mark. Up until 25 days, it's cheaper for you to be a non-member. So what's the point of that? Non-members, short-term solution. Members, you're going to go on for a lot. The idea is you're going to stick around a lot longer. So that's a real-life application. We set up the formula, and then we solved it. Okay?